Everybody loves music, and what better way to listen to it than visually? You might wonder what that's got to do with a traffic signal. Well, my friend gave it to me last year, and I think what we're going to do is turn it into an Arduino-controlled color organ. Now, if you've ever been to a concert or any other type of music venue, you've probably experienced a color organ, and basically it's when a series of lights flash with the beat of the music. And what we're going to do is transform this traffic light into a color organ where the green light flashes with bass, the yellow light flashes with mids, and the red light flashes with highs. Or you could do it the other way around, but we're just going to go in that order. Before we begin, a few basic things about traffic lights. There's two main styles of traffic light. There's 8-inch lights and 12-inch lights. This light is an 8-inch light. I also have a 12-inch light, and it's about twice the size. As you can see, this one will fit on a desk and doesn't take up a whole lot of room. And the next thing that is good for our use about this light is that it uses regular incandescent light bulbs. That's a lower wattage bulb than the one that came in it because the ones that came in it were not energy efficient, and so I switched them out. And most newer traffic signals are going to have LED bulbs or LED modules in them. And the way those work, as my 12-inch signal is a LED, is it'll have two wires coming in that take in 120 volt power, and then within the module it will convert it over to 12 volt. And these bulbs here just have two wires coming in, and so they're pretty easy to deal with. If you wanted to straight wire one to where it's on, you could just take all of one color wire and tape them together, and take all the other color and tape them together, and when you plug it in you would have 3 lights on. But that's kind of boring, so that's what led me to want to do this color organ project. Basic things you're going to need for this project are a traffic light, or you could really do this with any other kind of light that has more than 3 sections or less than 3 sections, but we're going to do it with a traffic light. You're going to need this little board, which is an MSGEQ7 breakout board. I purchased this from eBay from these guys at wazoo.com. They're the makers, and I highly suggest this one. This works really well. And the point of this is an equalizer board for the Arduino. So this will take any line level input, whether it's out of a phone, a laptop, or a receiver, and it'll convert it into 7 bands, just like an equalizer. And we're going to use the Arduino to detect those 7 bands and tell it when to flash the lights. So MSGQ7, you can either just buy the little chip, but I'd recommend for $15 buying the whole board. Next thing you're going to need is an Arduino. Now the mini Arduinos will work just fine. I happen to have a few of these Elegoo R3 boards lying around because they're cheaper than the originals, and they seem to work just fine. This is a full size, but basically any Arduino will work. The next thing you're going to need is a relay board, and these are solid state relays. These are by Sane Smart, same thing, bought these on eBay for not too much money, and I went with these over a traditional relay because I figured I didn't know if the traditional relay would be able to keep up with the frequency, and I also didn't want the constant ticking sound as they ticked on and off. And so basically the point of this relay is we connect one channel of the relay, one relay to each channel, if you will, and each of those channels will go to one of the lights on the traffic signal, making it flash off and on. A few other odds and ends that you'll probably want but are not entirely part specific are an enclosure in case you plan on using this thing outside or just to keep it a little more organized. You'll probably want a soldering iron in case you want to solder all your connections, and to go with that you want some heat shrink. You could use butt connectors or tape, but I'm going to solder mine in case it gets moved around a lot. And you'll also want some form of power cord for the 120 volt side of this operation, and this is just an old, I don't know what it is, it was an old thing that I hacked the end off of, and that'll work. Another thing you may want that's purely optional, but my project is going to use it, is some sort of switch. Now what you really just need is a single pole double throw switch, which is otherwise known as an on-off-on switch. This is a double pole double throw, but we're just going to use half of it. And the goal of this is to have the switch to be flippable to where one position is constantly on and all the lights are just on if you want some ambiance or whatever you do with the traffic light. And then we can flip it the other way and it'll receive the musical input and flash the lights accordingly. And that's just so it doesn't get stale. You know, sometimes you might want all the lights on, and sometimes you might want to do it with the music. One thing about this switch is that it does not have an off position, so you have to, excuse me, you got to deal with the turning on the Arduino board and the 120 volt power to sort of control your off and on main power of the lights, but that's no big deal for me. Now I'm choosing to work from the board to the light. You could work backwards from the light to the board, but the first step that I'm taking is to lay out how I want all of my components in the enclosure. And there's a few little things to consider based on the last point. We know we want everything going to the wall or to another source to come out of the bottom here, and we want everything going to the light to go out here. And so I've sort of lined this up. I'm planning on putting the MSG EQ7. I'm actually probably just going to mount it internally here, and I've got some stereo plugs and jacks, and I'll probably just make a little extension with a flush mount jack right here, so I can, you know, have a little more stability when you're plugging in and unplugging that instead of relying directly on the board here. And we're also going to need our power for the Arduino. Now you could use USB, but I've got some cheap wall wart adapters, and so I'll probably just drill a hole there and run its end in there. And the orientation I've got between the relay and the board is mildly important. We're going to be using digital outs as well as one of the analog outs and the 5 volt and ground, so we kind of want to have, you know, easy access to there. We don't want to be going all over the place and getting our wires messed up. And then here's where we have the connections to the individual lights, so we're going to drill a hole there. And then on the side I'm just going to mount the switch somewhere on here where it's in easy reach and kind of out of sight. So the next thing to do, I suppose, is to go ahead and drill our holes and get this figured out. So I did a little drilling, and here is the basic layout of the board. I have the relays here, the Arduino here, and I'm going to attach the MSG EQ7 board there. And as you can see, I put in a male 3.5mm plug, and I had some panel mount 3.5mm jacks, and I ran one there, and I'm just going to take 2 wires and run them between the two, since sound quality is not that important, and this is just a little more rigid than the solders on there, and it's more convenient to have a sort of a quick disconnect. And then I've got holes for both the Arduino's power as well as the 120 volt from the wall, and I went ahead and installed the switch on the side of the box here. So the next thing to do is figure out what wires and what holes we need to put in the top for the wires that are going to the lights. So I know I said we were going to move on to the light side of things, but I just wanted to touch real quick on how we're going to power the 120 volt side of the solid state relays. My cord is a standard 3 conductor cord. It's got black, white, and green. Yours may only have black and white depending on whether it has the grounding plug or not. It's all dependent upon what type of cord you're going to use. But I am not going to be using the grounding plug or the shield, so we're just going to tuck that away. And we're going to be using the white and black. And the black is what I'm going to consider as our hot wire, as if we were doing it in a house. And the white is going to be considered our neutral. So the first thing we have to do is take this black wire, and we have to create a pigtail of sorts so that we have one black wire going in to one of the 3 of these relays. And if you were using 4 things, you would need 4. If you were using 8, you'd use 8. It doesn't matter. But we're using 3. So one type of wire that I like to use, since this is, you know, this is not 22 gauge no current wire, this is household current power, is if you go to Lowe's or Home Depot or Walmart, you can get a spool of lamp cord, and that's 2 conductor cord. And then I usually go ahead and tear the strands in half. And I mean, there's obviously other ways of getting wire, but you know, sometimes you gotta do what you gotta do. So essentially what we're gonna do here is connect all 3 of those together and then solder and heat shrink them on the wrong wire to the black wire there. Then the other end is going to run up, and we're going to tidy it up, and it's going to run into the relay. So we're going to have 3 wires going into the relay, and then we're going to have 3 more wires going out, and those are going to go to our individual channels on the lights. Now, I mentioned at the start of the video, the lights, just like this cord, have 2 wires going in, a hot and a neutral. And so what we're going to do is this white wire, we're not going to connect it to anything in here. It's just going to chill. And what we're going to do is on our output, we're going to connect this wire to a wire that goes all the way to the lights, and then at the light end we're going to make a reverse pigtail. We're going to take all three of those, they're actually striped wires inside the lights, and connect them together and connect them to this white wire. And so our end result is we'll have power going from here all the time into these relays, and they'll be acting like a gate. And when that gate opens, that's what's going to flash to turn our lights off and on. And then it'll go all the way through, and we'll have a complete circuit going into the striped wires and the white wire here, and that'll cause our complete circuit and give us power. So just a quick sort of briefing of what we're going to do next. Next thing I'm going to do is strip the lamp cord wires and get them soldered to the black wire and get a pigtail going here. And I'm probably not going to connect it because that wire is a little more difficult to work with, and we'll probably actually work on some of the intra-box wiring between the Arduino and the relay and the MSG Q7 and the switch. And the last thing we'll do is move on to the light, and we'll do some programming in there in between. So for the little 3.5mm extension from the MSG Q7 to the female panel mount jack, I am just going to use this hookup wire. And I was reading on the eBay page for the Wazoo MSG Q7 kit, and they said that the left as well as the right channel are read by the board. So what that means for us is we're going to go ahead and wire up the tip, the ring, and the sleeve wires. The channels I wouldn't guess really matter as long as they're the same on both ends. Since we're not going to listen to anything, I guess the worst that could happen is your channels could be switched or crossed. But the main thing we want to get right is the ground, which we're just going to ground to the sleeve. So I'm just going to use some of this short hookup wire and make a little extension. One quick note, if you don't do a whole lot of soldering, I don't, but oftentimes the weakest link when you do small stuff like this is not going to be the wire, but it's going to be the plastic here. So if you have your soldering iron up too hot, it's pretty easy to just melt that thing right out. I've done it on switches and plugs like this, so just control your heat when you're doing this. So here's the product of the extension. As you can see, we'll have the line coming in. That'll be our music input source, and it just runs along here into the other jack of the MSG Q7, and the purpose of that is to give us a little more flexibility in mounting this, and for some structural support, because this is not very strong and I'd hate to get that ripped off in a quick disconnect or something. And the next thing I did is I went ahead and made some color-coded wiring here for the relay board. Got the power wires as well as the light channel wires, and the next thing I'm going to do is start figuring out how to wire all that up in this box, find out what needs hot and what needs ground, and try and make it all look halfway decent. Alright, so I've gone ahead and connected all the powers and ground that need to be connected, and I've also gone ahead and connected the light channels from the relay board to the Arduino, as well as the switch to its pin on the Arduino. And as you can see, I've got it plugged in, and we show nothing on the relay board, but when we flip the switch, channels 1, 2, and 3 light up, which is exactly what we want. And this is going to be the mode where all the lights are on. But just sort of as a recap, I took the power, 5-volt, and ground out of the Arduino and soldered it all together in T's. I had to make a few of them because I made a few mistakes. But the end result is the power comes out and it T's here and goes to the switch, and the other T goes this way, where it forms another T and goes to the MSG Q7 and the relay board. So as long as you've got power and ground coming out of your Arduino and going to the relay board, the switch, and the MSG Q7, it'll work just fine. So things look a little different. That's because I had to take some time off from this project, but I do want to pick back up where we left off, hitting a few things real quick. Had to redo some of the wiring, and I also got some screws and nuts, machine screws and nuts with small standoffs, and I secured everything down. I'm going to have to do a little work to this one. I put the hole in the wrong place, so the board's kind of riding a wheelie here. But if you'll notice, I left off in the same place we were in the last video. Got all 3 lights on, but now I've connected a 3.5mm audio jack to my iPad, and we're going to fire up some music from the YouTube copyright-free library. And since I don't have a splitter and can't make the iPad play out the headphone jack and the speaker at the same time, I'm going to be overlaying the music. And keep in mind, this is just kind of like a starting point, just to make sure everything's where we want it. We'll hook up the actual lights and tune the code a little bit to make it more representative in a little bit. But until then, I'm going to go ahead and start the music and start the overlay. So first thing we're going to do is flip it over to the other mode. And as you can see, we got no lights on now, and this song is called Church of Eight Wheels by Otis McDonald, and I picked it because it's got some bass, mids, and highs. It's got a little bit of everything, and so we should be able to see these lights flash. And I'm going to turn the volume up and down on the iPad to show the different. It's volume sensitive, so when the volume's low, you won't see anything. But I'm going to start with it wide open, and I'm pressing play now. As you can see, we have activity on all three of our lights at different varying degrees as the music plays. And the iPad is still alive, so we haven't fried it yet. The last thing we need to clear up before we move on to the light end is the 3 hot 120 volt wires that are going into the relay board. And now we're dealing with big power. It's main current 120 volts, so make sure this is unplugged. I went ahead and unplugged the Arduino from the transformer. And what we're going to do is take one of these wires and put it into either of these screw terminals. I prefer to use the same one on every one. We're going to put one wire in 1, 2, and 3. So I'm going to go ahead and do that, and then we'll move on. So I cleared a lot of things off the work table here, and I've brought the light up, and we're going to actually begin working on some of the wiring on that end of things. You'll notice that each one of these sockets here has 2 wires coming out of it. One is a color, and then one is that color striped with white. For instance, the red one here, socket's up here, it has a red wire and then a red striped wire. Yellow's got yellow and yellow stripe, and then green has green, and it's pretty corroded or pretty worn out, but green stripe. The first thing we want to do is take all of one example of the wire. I'm going to use the striped versions and tie them all together, and that's going to be our neutral. And then that neutral is, if you can see, I put 2 jumpers there, 2 of those paired wires, totaling 4 wires. I put 2 of those to the head and they come out the other end. What we're going to do is we're going to designate one of those as the common neutral, and I'm going to use the one with the black shrink wrap there. So we're going to take all the striped wires and connect them together with that one with the shrink wrap on it, and then we're going to take the other end. I'm going to have to use a meter. Nope, no I'm not, it's right there. It's got shrink wrap on that end, and I was wrong a minute ago. We're going to connect that one to the lone neutral wire here on our 120 volt plug. So I was wrong when I said that we're done in the box, because we're not. So that's what I'm going to do right now. Alright, I've got those all connected together. Ideally you would use solder, but I'm impatient, so I just went with a wire nut. The next thing I've got are 3 different pieces of shrink wrap cut in half, making 6 pieces total. One's red, one's green, and one's yellow. And what I'm going to do there is I'm going to put 1 piece of shrink wrap for each color on each end of this wire. For example, we'll have a red, a yellow, and a green, and then on the other end here, coming out of the traffic signal, we'll match those up so we can keep track of what wires go where. And at this point, it does not matter which wires you put the heat shrink on, because you can move it around relay to relay. We're just trying to make sure the wires, we have the same color on each end of the wire so we don't get crossed up. So that was pretty easy. Again, I went ahead and just used wire nuts. Got the wires connected to each other, and on the other end I went ahead and put the matching color of heat shrink. And next thing we're going to do is button up the light. Go ahead and close it up and start dealing with our connections from the coming out of the light and going into the box. So I've got the light all buttoned up. The next thing we're going to want to do is go ahead and connect the colored wires to the corresponding channel on the relay board. So you can see green is 3, yellow is 2, and red is 1. The only other thing we might have to do is I might have to add a little jumper for this neutral wire to get all the way over here to this one, just so there's not so much strain on it. So I've got a spare piece of the lamp cord that I've torn in half, and I'm going to probably go ahead and do that, but you don't need to see all that. So next time you see it, we'll have the light connected to the relay board. So I am back, and as you can see, I've got the wires from the lights hooked up to the relay board, and I also made that extension for the neutral wire, and that can mean only one thing, and that is that it is time to plug everything in and see how it works. So I've got the Arduino and the 120 volt power plugged in down there, and I've got the power strip off, and the switch is in the all lights on position. So I'm just going to use my foot here and flip her on and see what happens. We've got light and we've got lights. So this is our all on position. I'm going to go ahead and flip the switch to the other position. You can see they go off, but that is no big deal. Next thing we're going to do is hook that music back up and see how well it flashes. Alright, so we've got the 3.5mm cable hooked up, and the power strip is back off, and the switch is turned to all on mode. Go on and turn the power strip on. It's also plugged into the iPad. We're hopefully not going to turn the iPad to a fry pad. Flip the switch, iPad's still good to go, and we've got all the lights on. We'll go ahead and flip to music mode. Lights go off. Got the same music, ready to rock and roll, and hitting play. Move the lamp out of the way. Go ahead, play now. And as you can see, the music is flashing. So this is definitely a sign of a successful product. We still have a few things to do. We need to go into the code and see how sensitive the lights are. You know, we don't want it to be strobing all the time. But overall, this is pretty successful. That means the only things left to do externally are to put the cover on the box and mount it to the light. So I'm gonna go ahead and put the cover on. I'm not able to mount it on the light because I'm not quite sure how to secure it yet, but we can at least start to button up the process. So here we are looking at the code for the color organ project, and the first thing I want to do is give a big thank you to 3 people here. The first is Mike from mikestechblog.com. He also did an Arduino powered color organ, and his used LEDs, and so I got a lot of great information from his article there. Next is Great Scott, the YouTube channel. If you've done anything electronics related, you've likely seen at least one of his videos. And finally is Peter Easton of Wazoo.com. He's the one that made the MSGQ7 breakout board. So without those 3, I would probably not have this code here. Most of this code comes from a combination of those 3 sources, and I've just changed some numbers around and added a few small things. So big thank you to those 3. And I'm just going to, obviously this code will be posted in the video description, but I'm just going to give a few overviews of things you might want to change for your color organ to get better results. The first thing I want to mention is this comes from Peter Easton, and that is that pins analog 0, 7, and 8 are MSGQ7 specific. So you need to have analog 0 as your out, strobe is 7, and reset as your 8. Switch is number 6. That's the one I chose to use. You can use any pin on your Arduino that you like. I use digital pin out number 6. Next thing I want to get into is this filter value, and this essentially is a sensitivity for your color organ. If you have the value too low, then your lights will pretty much just stay on all the time, and about 100 is as low as you can go without them just staying on all the time, but I like about 250, and this will obviously vary depending on whether you're using LEDs or non-solid state relays or what. Next part is where we assign what pin goes to what light, and these obviously same thing. You can use any outputs on your Arduino, but I went ahead and just labeled them for the color of the light. Next thing we do is start the serial reader and set our inputs and outputs, and then we begin the loop. And the first thing there, this is where I added in the switch, and that's switch value, and that's digital read pin number 6. So you may have that different there. And then we start telling it, first thing it's going to do is read the value of the switch. And it says if the switch value is 1, we're going to start the strobing cycle and go through here and change all of this stuff. And one thing you might end up having to change on here is the delay. That's if you are using incandescents, you might want to turn that up a little bit, and that'll give your lights a little time to dim and maybe have a bit higher definition in your flashes. And now this part of the code was all three of the examples I've used up here used LEDs for their project, and so the goal of this part of the code here is to handle dimming the LEDs using pulse width modulation, but it works just fine for our 4-hour solid state relays, so I decided to leave it in, mostly because I don't know a better way to do it. So what we're doing here is assigning each light a value to go with, and for this project I wanted one base or low, one mid, and one high. And when I first started, I had one of these lines for every band that the MSGQ7 could read. For example, there'll be one between 63 and 1000, then one between 1000 and 6250, and a few others. But what I did was I went ahead and deleted some of them, and the point of that was to give a better example of one low, one mid, and one high, because I found if I had, for example, the green light on 63 hertz and 1000 hertz, that's a lot of range for that one light to cover, and there's a good chance that there would be something in that frequency almost all the time causing it to light up all the time. So if I had to do something different, I might use one higher band for the red light and then just bump the 1000 up to 6250, because you'll find if you do this or if you watch my video that it's pretty yellow heavy. There's a lot going on in this 1000 hertz range. So back to real time here, and as you can see, I've zip tied the control panel control box to the back side of the light just until I can get some self-tapping screws to permanently mount it. And I wanted to go back a little bit and say that my inspiration for the color organ came from this kit that I bought online. This is supposed to be a 3-channel color organ kit that uses the potentiometer to control sensitivity and uses those MOSFETs to control the lights flashing. But from the time I bought this thing, it never worked at all. I don't know if it's a problem here in the transformer or the potentiometer, because I followed all the instructions perfectly and it just never worked at all, and I ended up abandoning it because this was about $25, and for pretty much the same price you can have the Arduino powered version, which I think is much cooler because of the customizability, and it's also neat, I think, because it uses digital technology versus analog. But this is another option if you're trying to do a color organ. I just would recommend you skip it and go for the Arduino. And speaking of this color organ, this is just something that I've tried, and if your house catches on fire and burns down, you probably don't want your insurance company to find this, and likewise it might, you might have different varied results. So just use some common sense. Part of it is using 120 volt household power, so make sure to double check, follow the wiring diagram that I've posted, and you should be good to go. So thank you again for watching. I appreciate it. I'm going to try to get back to posting more consistent videos. I've had a lot going on and just haven't been able to get around to it, but I did reach 1,000 subscribers recently. It's not a huge deal to many people, but I think it's pretty cool. So this is the end of the color organ project. Again, I appreciate you watching, and I'll see you in the next video.